Hello, everyone, and welcome to today's webinar. This is the 7th episode of our 12-part webinar series on countermeasure strategies for pedestrian safety. Today's presentation is going to focus on the leading pedestrian interval, or the LPI. The presentation today will first be delivered by Margaret Kublins, who is a traffic engineering manager for VHB. We'll also be hearing from George Branyan, who is the pedestrian program coordinator for the Washington, D.C. Department of Transportation. We're really happy to have Margaret and George here today. My name is Dan Jeline, and I'll be facilitating today's webinar. Attendees, if you can hear me, I'd like to ask you to please click the hand icon that's located in the upper right-hand corner of your screen. If I see hands going up, that means that you'll be able to hear me, and we'll know that everything is working properly. So starting to see those hands going up. Very good. Excellent. Very good. All right. Well, really glad to have you all here today. I think we've got a great show planned out. We're looking forward to getting into it. Before we get started, though, I just have a few things that I'd like to go over with you, a few administrative details about the functionality of the webinar software. If for some reason the computer freezes during the session, please just reload the website, log back into the program, and you should be able to rejoin the session. We'll be loading and posting the presentation slides in PDF format, as well as a recording of this webinar to the PBIC website. So you will be able to look back at anything that you missed during the show today. The presentation slides will be available later today, and the video archive should be up within about 1 to 2 weeks. Please note that the attendees will not be able to speak during the webinar, though you will have the ability to submit questions to me in comments using the chat function. Please feel free to ask questions at any time during the presentation. We're going to be holding about 20 to 30 minutes at the end for a discussion session with our presenters. Later today, you'll be receiving a follow-up email from the UNC Highway Safety Research Center with a link that will allow you to generate a certificate of attendance for this webinar. It's very important that if you are attending this webinar with multiple attendees at your site, please be sure to forward that email on to those folks so that they can also produce a certificate of attendance. Link to the website where we'll be posting the presentation materials from today's webinar. The link is also going to take you to the page where within 1 to 2 weeks we'll be posting a video recording of today's session. The webinar today has been submitted to and approved by the American Planning Association for 1.5 CM credits. I'd encourage you to please go online and check the online AICP event calendar for more information about how to claim those credits. If you want to learn more about PBIC webinars or check out our past webinars, you can log on to pedbikeinfo.org/webinars. I'll put the next slide up. Many of you have already attended past episodes of this particular webinar series. Some of you may be attending for the first time. Welcome. We're glad to have you here. I'd like to just mention that all of the sessions, the previous 6 episodes that we have presented, are all posted online for you to go back and watch if you did miss them. And then the next 3 webinars are listed here that are coming up in the series. We're actually going to be doing 3 more within the next couple of weeks. And so you'll have plenty of opportunities over the next couple of weeks to learn about some different safety strategies for pedestrians, including safety at interchanges, lighting strategies, as well as traffic calming strategies. So take a look at these. We also have a couple more sessions that will be coming up in January of 2016. So I'd encourage you to sign up if you haven't already, pass the information on to others who may be interested. Before we move on in our presentation, I have a quick poll that I'd like to take from the audience. We're interested in finding out how many people are attending from each of your sites. So if you could take a few moments and cast your vote in this poll. We're just interested mainly in finding out if it's just you attending the webinar from your desk, or you have some other folks with you, a small group, maybe a larger group. We're just trying to figure out how people are attending our webinars and how many people are out there. So take a few more minutes, or a couple more seconds, I guess, and we'll, without too much more delay, we'll move on with the presentation. Okay, very good. Just a few more seconds for the poll. We'll close it up. Cast your vote if you haven't already. Okay. Very good. Thank you all so much for that. I'm going to go ahead and ask Margaret to get set up with her presentation. Margaret, you should see the alert come across the screen to take screen control. And whenever you're ready, please do so, and you should be able to broadcast your slides.
Okay, that sounds good, Dan. Thank you. Let's see. The purpose of this module is to describe a low-cost signal timing tool that can minimize pedestrian crashes with traffic turning across crosswalks at signalized intersections.
Hey, Margaret, I hate to interrupt. I can actually see the slide notes on your slide. I wonder if you have a view where it could make the slide bigger on the screen without you.
Uh-oh. Let's see.
All right.
Whoop. Sorry. Should have tested this.
Go into slideshow mode from here. That should. Okay.
How about that?
That's perfect right there.
Okay. Everyone close your eyes. I'm going backwards.
That's all right. Thank you, Margaret, for that.
Sure. Okay, let's get started again. So this is a low-cost method of improving traffic safety for pedestrians at signalized intersections. Just to explain, a process associated with the traffic signal cycle. What I have in this diagram here is a representation of a signal cycle. It's just a simple two-phase traffic signal that would be operating, and the representation here is how you have your main line green, and then you move to your clearance intervals. So you have your yellow and then an all red, whoops, and then you go to your side street green, clearance of yellow, and then all red. And then on the perimeter of here, what I've shown is how the pedestrian signal comes up. So this would be your walk on the outside. Then you go to flashing don't walk, and then you would have your don't walk during the mainline clear, and then you would have an all red indication out on the signals all the way around. And then similarly, you go to walk on the main line, and then you'd have your pedestrian clearance, and then you go to your don't walk during the side street clearance, and then you have all red. So that's your standard traffic signal operation that you would see on the street. Now the leading pedestrian interval comes from a 3-second, it could be about 3 seconds, that's the minimum recommendation, where the red is held on the street for the traffic, and the pedestrians actually get about 3 seconds to establish themselves in the crosswalk before the traffic gets their green. And this is just a simple representation of how that occurs. So what the pedestrian sees out on the street, this is a car over here, and then the pedestrians are over here. There is a film that you can go visit that's listed right here at the bottom. This is the link to it. But it's about a minute long. Unfortunately, it just won't cover and broadcast through this capability. There's too much stutter. So we chose to represent it here. So your car has a red, your pedestrians have a red, and this is where we start that green phase. And then you have your pedestrians, they get about 3 seconds to cross the street, and they assert themselves into the crosswalk. The car still has the red, that's that extension of red, and then the car gets their green. So they would be passing behind the pedestrian after they've already started their crossing of the intersection. So let's jump right into a case study so you can get a feel for this, how this can be implemented. In St. Petersburg, Florida, they had a study that they performed. And then they had, at the locations, they had high incident of crashes. And it actually came from the left turns. Left turns and right turns are handled very similarly as far as the calculations go and how you want to address it. So they had, they focused on left turn motorists. They used 3 intersections that they did their evaluation for. They had locations where the pedestrian crossings averaged 60 per hour. And just so the results were not biased, they did no public outreach or awareness because they were looking for that behavior just intuitively. So they did the 3-second LPI, and what they found was very positive, and they were meeting the goals that they had intended, where they had the pedestrian asserting themselves, and then they had a strong yield rate by the vehicles. And we recognize that if I've looked through all these case studies, that there's a high level of efficiency that occurs at the intersection just because there isn't that hesitation by the cars and the pedestrians as much, because they know clearly that the pedestrian is stepping out. In their study, they had all the intersections had 4 lanes in each direction, and they were at a posted speed limit of 30 miles per hour. As they were doing the data collection, this is all before and after, the pedestrians and motor vehicles had the conflicts. They were counting how many times they would have conflicts. They had they were counting how many pedestrians were crossing in the first 5 seconds, and then they also looked at how many people were starting to cross at the remainder of the walk. The results were showing that the conflicts virtually eliminated, and before they had 2 or 3 conflicts per 100, and then afterwards they had there was no observation with more than 2. And they had done evaluation of 41 periods that had no conflicts whatsoever, which was very positive. In the ITE toolbox, the LPI is shown to have a 5% decrease in the pedestrian crashes, which is very, it seems to be less than what was expected, but it might be time to update some of the information. Later on, we did do some updates and found some crash modification factors. The gross phage study came out in 2009, and that was showing very positive results for, and the calculation coming out with a 37% reduction in pedestrian crashes. So we do have that information documented and can be used for calculating the effectiveness of increasing the safety of the intersection. MUTCD now has specific information relative to the LPI. Before, it was in there in a less bold way. It wasn't explicitly stated, and now it is, which is very important for all of us in order to reference it. I know a lot of engineers, we tend to be conservative, and we want to have that go-to document to back up any conditions we want to go forward with implementation. So at the intersection, we want to make sure that our pedestrian signal heads are clearly indicated, and they can also see what is happening for the through traffic at the same time. As far as what we need to do with the accessible signals, it's very important that if you are installing the LPI, even though it's not required by law, it should be considered. ProWag doesn't have it passed yet, but it is, the accessible feature is very important because the blind or visually impaired pedestrian is relying on the traffic. They want to listen for the traffic moving adjacent to them because that's how they're trained to use the street system. And without having an audible walk sound or a beeping, depending on what you're installing, they don't have an indication to know that it is safe or it is the time for them to cross. So it's important to add the APS if you have that capability. When we're calculating the LPI, the minimum is 3 seconds. That's the duration that is should be used. But then there are other things to consider as far as how to determine the crossing distance. You want to get them at least through the middle of the curb lane. So it's important to understand that the 3 seconds allows them to step off the curb and start walking into the intersection, but like if you have parking or you have a wider lane or if you have a very wide turn radius on a corner, you want to make sure that you have enough time for that pedestrian to assert themselves. And we're going to go through an example that shows how to make that calculation in a few minutes here. So the 3 seconds is the minimum from MUTCD, but you certainly need to tailor it for your conditions. Everything that we do and we're suggesting here is make sure you're designing for the context. Recognize that you may have slower pedestrians because you may have an elderly, or you may be in a condition if you're near a school, especially an elementary school. You want to make sure that it accommodates the younger children across the street. At a college, you may be able to get away with something a little bit quicker. So recognize the context that you're designing for. LPIs are being used nationwide. So DC, this is data that was assembled back in 2014, so this may be a little dated. They had 117, Philadelphia 24, Boston had some, as well as Phoenix. State College is a reference as well, New York City, so it goes on and on. So you may, if you're not using this in your state, you may want to call up some of your peers and solicit information from them as well. So in Phoenix, they did a study and they used 2 one-way streets when they first looked at their implementation, and they used a 5-second LPI. Sometimes if you're addressing your left turn conflicts, you'll want to probably use a little bit longer LPI so you can get those pedestrians fully in the line of sight of your left turn vehicles. They had locations where it's heavy left turn movement, and then this was right outside City Hall and City Court, so it had a lot of pedestrians in the area. These straight line representations here are similar to the circle that I had at the beginning of the presentation. So this is at 3rd Avenue. You have red here, and then they see green for 27.5 seconds, and then they have their yellow and red clearance, and they have their 35 seconds of don't walk, and then they have their 19.5 seconds of walk, then 13 of flashing don't walk, and then 4.5 of don't walk. So this is the corresponding pedestrian crossing here, and then this is that 5-second LPI. This is where you see it. And as far as congestion and impacts on congestion of traffic moving through the corridor, the studies are showing that it doesn't have much of an impact, if at all, because there is some efficiencies in there without having that lost time as people hesitate on, okay, are you really going to stop, driver, versus the pedestrian, being able to just walk straight out there. This can work for, this can work for both fixed time and actuated signals, and your controllers can accommodate it either way. Some of them, if you have an older controller, it may need some techniques to be forcing the LPI to be worked in, but your savvy technicians will be able to accommodate it. Okay, so here's the handbook for the design of roadways for aging populations. This is the formula that you may want to be using in your jurisdiction as far as how to calculate how long your LPI needs to be. So you measure the width of the moving lane. So let's say you have a 12-foot moving lane, but you don't have a parking lane. If you have this condition, then it would be 12 plus 6, so that's 18 divided by 3, so you use an LPI of 6 seconds. Let's say that you had a parking lane as well. So you have 12, and let's say that parking lane is 8. and you add the 6. So you have 26 divided by 3, and that gives you an 8.6 second leading pedestrian interval. So this represents how you do those calculations, recognizing that 3 is a minimum. Boston has a complete streets guide that they formulated or they established, and so they look in their urban area, they have a 3 to 7 second LPI, and they consider if there's higher conflicts, or it's considered if there is a location where you have high conflicts between PEDs and turning vehicles. They use a lagging left turn arrow, and they want to make sure that the turning vehicles are actually yielding to the pedestrians, and then they use the accessible, the audible pedestrian signals. They also have conditions where if they have a lot of left turns or right turns at the end of the don't walk or the flashing don't walk, and then they go to a steady burn don't walk, then they'll sometimes add some through line green for those turns to accommodate any capacity issues that they had associated with the LPI. So they actually shift the green time and take it out of the next phase. So that's another consideration, that you may need to extend your green time at the end since you've already accommodated the pedestrian, and it kind of works in the reverse direction. Other things that we haven't talked about yet is no turn on red signs. I'll show you a couple of versions of that. And they also implement using the leading bicycle interval. So it's similar to the same conditions that we're talking about with an LPI. And if you have bicycle signals, you could use it there as well. And that would probably help with your right hook conditions, risk, and with your bicycles. So in Toronto, they have, you have to choose the greater in their recommendations on calculations. You have to choose greater of 5 seconds or the distance to clear, the divided by 2 plus the parking lane divided by the walking speed. And these are all the considerations that they have in their calculations and their determination of where to apply the LPI. And then they have a chart that they use to score. And so they've gotten to the level where they're establishing a methodology to evaluate the conditions. So they have a go-to document to say, yes, this is what we want to do. And then they actually have, once there was a location that had an LPI before they had the guidelines, but then after they followed through on the guidelines, they removed that LPI because it didn't reach their score of a 5 or better. So they wanted to measure the total impact on vehicles using the intersection. I went the wrong direction again, sorry. High-level potential safety improvement, so they're measuring a variety of conditions that would have favorable results. So they're looking for a score of 5 or better, and then that way they know whether that would be a good candidate for the conditions. Here they mentioned the elementary school, whether it's located near an elderly facility, or where they know that there's several elderly individuals. Okay, so now moving on to a little bit with the signage that you may want to install, and it is recommended to install some no turn on red signs. And the most the most effective is going to be your blankout sign, and that is wired directly with the pedestrian push button and the phasing. And that is very effective because it's on and off. These other two versions or the other three versions that we show here, no turn on red, no turn on red, and then here as well, they don't have as much prominence, and because they're seen so frequently, they kind of blend into the background. Where this is a change, it's blank, and then it just comes on when you actually need it. Signal controllers capability. There's a lot of controllers out on the street. We recognize that, but there's also a lot of opportunity. Like I said before, the savvy controller technician or traffic signal technician probably knows how to work in a dummy phase to make it work. They can do some amazing things. You just challenge them and they'll do it, and they'll figure it out. But it does require a dummy phase on some of the older machines. Use delayed green feature. That's another way of doing it in the some other controllers. I don't want to really get into a lot of detail on this. Let me see. See, this is where I wish I could just ask questions but couldn't the audience. Okay, so the newer traffic signals can accommodate it. And on the same line, when it comes to many of the people on the line probably have more interest in understanding how you may want to model this in Synchro or VisM as you're trying to test it and justify the implementation. If you're actually doing it in Synchro, you can just modify the startup loss time, and so you can extend that and make it a little bit longer. And so that's how you can do it in Synchro. And then if it was in VisM, you could VisM now actually takes it in and allows for for you to model the LPI in there. So those are two things that would be important probably to you. Okay, some of the issues, things to consider as you go through and you look at implementation. The left turn arrows, that's with the lagging protected arrow. That does work very effectively. If left turn arrows are very good for pedestrian safety and having the protective phase in there. The right turn arrows can help as well. So think about how you're doing that implementation with the arrows and how all that works. Synchronization with other signals, that shouldn't be an issue. The coordination is important. It just is worked in when you're actually doing your progression, your time-space diagrams. You're syncing along there, and your phase 2 and 6 should be, the coordination of those shouldn't be affected by that. On one-way streets, you still treat it the same way, whether it's right turn or left turn. And this is where I mentioned before, on a left turn you may want to make it a little bit longer just so that pedestrian can get out a little bit further if they are on the left side of the travel lane. So if you're trying, your main concern, conflict with left turns, you're going to want to have that pedestrian in the street a little bit longer than what you may be in consideration for your right turns. The no turn on red and right turn on red prohibitions are going to be very important as well. Those, like I mentioned before, the blank out signs are good to keep those cars back to where they belong, back behind that stop bar so they aren't trying to jump ahead. And the congestion should be a little bit better, you know, a reduction in the congestion just because you have a more efficient use of the cycles, because you're giving that right of way at a sooner period, and you're going to sort of bunch people together. It's sort of like platooning cars. You're platooning the pedestrians and getting them moving as a platoon before they start getting all spread out. So the effectiveness comes through the use of signs, protecting or prohibiting the turns, and using of the accessible pedestrian signals for the vision impaired. The cost is very low. You have the effort, the time and effort to program and implement it, so it is pretty low. There's some engineering study that may be required by your jurisdiction. They may not allow the traffic operations group in order to install it without having some sort of study. The signs, and then you have your APS push buttons. So the cost is very low compared to so many strategies that we like to implement. So I just have a few case studies to go through. State College, Pennsylvania, they had high pedestrian vehicle crash rates, especially in the central business district. And when they first did their implementation, they had 10 intersections where they implemented the LPIs in their downtown area, and each street had 2 through lanes. And the ADTs were 12 to 13,500. Speed limits were 25, and high number of pedestrians per hour. They used the 3-second LPI, and the results showed that it was very effective. They had the period that they evaluated before and after. The treatment group was 24, and the comparison was 13 and 17. So that's how many crashes they were able to reduce, or those are the crash rates that, the crash counts that went down, sorry. New York City, they have several locations where they have implemented them. Here is a link to their information of all the signals where they have LPIs. There's quite a few. And again, they have very positive results that they've experienced there as well. Here are the resources. This is all going to be on the up when Dan submits the slide presentation. And I think this is where we can go back to Dan and we start taking questions.
Okay, great. Thanks very much, Margaret. I'm actually going to, before we get to the questions, probably turn things over to George Brannion to talk about the experience in Washington, D.C., and then we'll all be able to have some question and answer time after that. So, George, if you want to take a look at your screen, you should be able to, yep, I see your screen now.
All right, everybody can you hear me okay, Dan?
Yes, I can. Thank you.
Okay, excellent. Welcome, everybody, whether it's good morning or good afternoon to you. I'm George Brannion. I'm with the DC DOT, and first I want to thank Margaret for that very detailed overview of a lot of the issues to be considered and operationally and all the factors that you want to consider and look at. I'm just going to give a fairly brief overview of how what we've been doing in DC with leading pedestrian intervals, which we've been using since mid-2010. So to add to the overview, LPIs hold the red indication for drivers for 3, 4, up to 5 seconds more, depending on the situation. And the primary purpose is to reduce conflicts between turning vehicles and pedestrians. Most primarily in DC, it's the right turning conflict that we've had the biggest problem with. And that's a picture of 14th and U in DC showing our countdowns. We run the countdowns from the very beginning of the walk phase. At most of our signals, is as long as they are not pre-timed, or excuse me, as long as they are not actuated. If they are pre-timed, we typically run them the full countdown, so don't be thrown off by that. So in DC, we started putting them in 2010, and we are now at 162 intersections with LPIs. That's a little bit over 10% of our total number of signalized intersections. We use 3 seconds in almost all cases. We do have a couple locations where we've used higher number of seconds, like 5 seconds. Folks who may be located at the US DOT at Federal Highway know that the intersection in front of US DOT, New Jersey and M Street Southeast, does have 5-second LPIs. And of course, it's listed in the toolbox of countermeasures as having a crash reduction factor of 5%. And I'm glad that Margaret mentioned the Fayesh and Gross study, which we learned about last year in a designing for ped safety course that was taught here. That there is that study from 2009 that does show a 37%. I think probably in reality, in most places, it'll be something somewhere in the middle of that range, but that's a pretty good range. And then kind of a funny aside, in 2011, the city paper of DC does its best of DC in many, many categories, and they actually created a best pedestrian safety improvement category and gave it to DDOT in 2011 for the leading pedestrian intervals that have been installed up to that point. So that was a nice pat on the back, which we didn't expect. This is, again, we've seen one diagramming of how this works, but this is one I think credits either Dan Burden or Michael Ronkin for this slide, but it shows that typically the person walking and the car move at the same time, and that can create the conflict. When you give the leading interval to the pedestrian, then the pedestrian can get most of the way across and established in the crosswalk, and the driver will not conflict with them. That's the basic rationale. So from a practitioner standpoint, the selection process that we use in DC has been a lot simpler than some of the ones that Margaret spoke about and showed from other places. In particular, the Toronto example, I did see the TRB presentation of the paper by Shada Saninejad from Toronto, where they have, as you saw from Margaret's presentation, a very detailed process, an analytical process. We were a little bit less analytical, but we were still trying to focus in on the main problem, which is looking for places that had high proportions of crashes involving turning vehicles and pedestrians. We also take high complaint locations. We do get a lot of complaints at locations where pedestrians complain that when they get the fresh walk signal, that they are finding drivers in conflict with them. Those end up getting into a list. And then DDOT is still in the process of implementing a large signal optimization project, and as they've been taking new counts, intersection counts, they've been looking for the higher right or left turn intersections paired with high pedestrian counts, and looking for the ones with the highest conflict potentials and adding those to be LPI intersections as we gradually implement across the city all new signal timing all the way across the city. And so we've put, I'd say about a third or so of the city has undergone this signal retiming, and so many intersections have been added with that project. And then I'm glad that Margaret mentioned the effectiveness of the no right turn on red sign. That is key. I know there was an ITE study or an ITE magazine article about a study that showed that without right turn on red prohibition, the LPI is much less effective. We have in DC, the no turn on red is typically 7 to 7 and is fairly well adhered to because we don't have any other times. We certainly don't use the when pedestrians present type of sign. That tested poorly, I do recall in a study done several years ago. So either no time prohibition of any type or 7 to 7 works pretty well for us. So what I first noticed when I got here a decade ago is that we did have a very high proportion of pedestrians struck with the signal in the crosswalk, as this shows. These are all the different pedestrian actions, it was 23% over the course of several years, 2004 to 2010, continues to be fairly high. Sorry about that. And so this got me thinking, and so I went to the crash data, deeper into the crash data, and found that in this particular intersection, there were, I looked on the right side, you see the pedestrian action, and then on the left side, the type of collision tells you more or less what the driver is doing. So you have, I started noticing this remarkable correlation between the right turn hit ped and the with signaling crosswalk. And so this is a particularly bad intersection because I think we're up to 7 or 8 pedestrians struck in the crosswalk with the signal by mostly right-turning vehicles. And again, they're mostly right turn in the district because lefts, we have very few left turn pockets and very few left turn phases, mostly permissive lefts, and so right turns are just happening a lot more. And so that was the problem that I thought the LPI could help solve. So what we've done is we put, as I said, about 162 in. This is from December of 2013, and this shows how many there were there. That was probably about 115 at that point, but as I said, we're up to over 160 now. They are clustered in the downtown area, in the business district, but we're adding them to other corridors. Connecticut Avenue had them added back in 2013, I believe, and so we're again looking for more opportunities to add them as we retime the signals and as we get more data in. Now the last slide I have is just a bit on the evaluation. The only thing I've been able to do is sort of do anecdotal, simple before and after comparisons, and I've seen what I think is a little bit of reduction in turning vehicle crashes with pedestrians at some of the heavy pedestrian exposure intersections, but we have not done any kind of statistically rigorous study, with control intersections and all that. But I restate the crash reduction factor there because this happens a lot in DC. Is people sometimes within DDOT and in the public, they want to know, is it working here in DC? And if you say, well, there's this wonderful study of another city or another state that showed a certain benefit reduction in crashes, they'll say, well, that's not DC, or that city's completely different than DC. So I tend to, as a practitioner, I don't have a lot of time to do research. This is still something we may do, or perhaps work with other cities and states to do a new assessment or a larger assessment. But I simply point to the research that's already been done to back up my argument that this countermeasure reduces crashes. In DC, we already have a lot of traffic delay, and nobody's blaming the LPI on that. But I will say that when I first pitched it to the signals team, I certainly said, let's start with 3 seconds so that we're not taking any more green time than we have to for this countermeasure, and that was accepted. So there was just sort of certainly an informal give and take once I went to the team with the crash data and with the concept behind the countermeasure, and it was greeted with a fairly warm welcome from our signals team because they saw it as taking very little green time and having very little penalty for traffic flow. And when you look at the number of pedestrians who are hit by turning vehicles, it's a pretty stark number, and it gets people's attention. So that's all I have.
Okay, very good. Thank you so much, George, and thank you, Margaret, kicking things off. We got some questions submitted through the presentation, so I'd like to get to some of those, and we can take it from there. We heard a lot of examples of how to use these for right turn restrictions and also right turn movements and as well as left turn. In your experience, and I'll pose this to George and Margaret, is there one movement that's typically looked at more often than the other in terms of the left turn or the right turn conflicts when putting in LPIs? George, you mentioned that's the conflict you noticed was the right turn. I don't know if, Margaret, is it more common for agencies to look at using these to reduce those left turns or the right turn conflict?
It seems from the conversations that I have and what I've read, it's more common to see how it helps the right turn movement. If we're always addressing the left turn, that's a long distance for a pedestrian to cross before you would release your left turn. So it's most prominent for relief for the right turn than it is for the left, but on certain circumstances you definitely want to look at the left.
Yeah, I would agree with that. We have some T intersections where the drivers have to turn right or left, so then you have a much higher frequency of left turns, and those are ones where the LPI can be very useful. But I think Margaret's right in saying that you need to go to slightly longer LPIs for the left turn. I think the example right down the street here in front of US DOT and New Jersey and M is a good example because we had the 3-second LPIs there, and we still had problems with the left turn, which is a fairly, it's sort of, that's probably more left turns at that intersection than rights because of the angle that New Jersey comes into that intersection, and it's a slightly soft left, which allows drivers to carry a little more speed. And that has made a difference. Just as a frequent user, I've felt that longer LPI does make a big difference on the left turn. So it is good to go, if you're concentrating or focusing on the left turn conflict problem, the longer LPI is the way to go.
We saw a sign, one of the many right turn on red restriction signs that Margaret showed, but one of them, Margaret, the one you liked in particular, was the blank out sign that when activated will show a no right turn on red message. Are you familiar with signs that will show that message and then through the green can switch that message to a turning vehicles yield to pedestrians sign to be able to duplicate that one sign for 2 different messages during a cycle?
I have not seen that, but I would expect that would be available.
We had a couple of notes about it in our comments, so I was just curious if you all had come across that. I have not personally, but it sounds like a very useful sign. That basically, you know, it seems that it adjusts the message based on the current circumstance, based on what the light is showing and what you're trying to convey. So.
I would add that I think that's a great idea, but we're not going to put the blank out sign up at hundreds and hundreds of intersections. The cost would be pretty prohibitive. But we do use the R10-15, turning vehicles yield to pedestrians or turning vehicles stop for pedestrians. We tend to pair that with the LPI because it's another countermeasure, a signage countermeasure for exactly the same problem, which is the turning vehicle ped conflict.
Mm-hmm.
Margaret, bouncing back to your presentation, you shared an example. I don't recall, I think it was the Pennsylvania example, where there was actually, they noted a cost savings of around $90,000, I think. Can you explain what the cost savings was attributed to?
Yeah, let me get my notes.
Sure. In some way, a benefit from improved efficiency in some way.
The study used, let me just read the notes from that. Okay, the study conducted an economic analysis as well to determine whether the countermeasure is cost effective. The study used an FHWA study that found the mean comprehensive cost associated with a pedestrian vehicle crash at a signalized intersection with a speed limit of less than 50 miles per hour is $164,000, and the cost of state college LPIs being $1 million per intersection in 2005, which included controller programming and the additional cabinet wiring, required to accommodate the existing controller assembly. Okay, let me go back through that a little bit and dice that up. Okay, it used FHWA study, and that is where it found that for the pedestrian vehicle crash being about $164,000 cost. And then the cost for State College for an LPI is about $1,000 per intersection. So they annualized the cost of the LPI, and it was computed to be $115 per intersection per year. So if the savings in crashes is greater than $115 per year, the study found the LPI is cost effective. Based on the reduction of crashes, because the reduction of crashes in that study was averaging about 59%, there was a cost savings of $92,000. Maybe, do you want me to bring that slide up?
Sure. Let me switch it back to you and see if we can pull that up. It's useful to look back at it.
Whoops. This is why I'm better with interactive face-to-face. Let's see. Where's that?
While you're working on that, Margaret, and pulling that up, I want to ask George. George, do you you talked a lot about your selection criteria. Margaret mentioned, some agencies that kind of prioritize locations that are near certain types of generators where maybe there are more elderly or senior populations, or maybe near a school where children are using the signal and need a little bit longer time to cross or establish themselves. Do you have any of those kinds of criteria that you look at when you're putting yours in addition to some of the more conflict-based, safety measures?
We did have one, the Connecticut Avenue corridor was done in sort of conjunction with an advocacy group, an elderly senior advocacy organization on the corridor, because along Connecticut Avenue we have some of the highest proportions of more elderly residents in the city. Excuse me. And so we did, that was something, they were looking for a number of pedestrian safety improvements for targeted towards elderly users, and so that was one of the ones we did, and we did it because it was a lot of elderly. But in other parts of the city, we haven't used that as a criteria yet. No.
It looks like, Margaret, you found the slide you were talking about.
Yes. So what they did is they did the calculation to 100. They recognize $115 per year in savings for each crash, and then with the 60% reduction in crashes, they did the calculation to come to $92,000 per intersection per year. That's how they came up with that value.
Very good. All right, and which is something other agencies could do. I'm not from, I wonder if there are other agencies out there that are kind of using the same sorts of kind of selling points for doing something like this. I was curious about the whether that was, I think maybe the person asking the question was curious about whether it was some kind of quantification of the cost savings for improving maybe efficiency, because it does seem like, based on some of the arguments you presented, the argument against an LPI may say that, oh, this is going to, cause delay and all those things, but you all, I think, were making the argument that it may actually have the opposite effect, or may actually prove to relieve some of the delay. Can you, Margaret, would you mind just outlining the reasons for that again? Why an LPI could actually improve throughput at a particular intersection?
Yes, because our models, let's say you're working with Synchro, and like I suggested, if you're going to model through Synchro, you may want to increase your startup loss time. But I would expect that even though we're modeling in Synchro, I mean, that's very driver-oriented. And let me go back to, here we go. If you remember, this is the main line. I would expect that there's efficiencies that are occurring here, because something that isn't always recognized is that there is, back in this kind of condition where everyone is red all at the same time, and all of a sudden your pedestrian gets their walk signal at the same time your vehicle gets their green. They may want to sort of jump the green, and so they're like chomping at the bit to get out of there, but then all of a sudden they're having to hit their brakes real quick. And so right at the beginning of the green and the pedestrian walk, there's some inefficiencies here that we don't always capture in our startup loss time, especially if we're just looking at the 3 seconds. And then what happens is that you get, when you have the LPI, during this first 3 seconds, you have that pedestrian already moving and almost getting out of the way when this green starts for the vehicle to start moving through there.
Okay.
And I haven't modeled that and then correlated that back to what was happening in the street. I've seen both. I've seen it happen in the street,
Yes.
but the modeling is a little less accurate.
Okay. We had a lot of questions about comparing an LPI with something like an exclusive pedestrian phase or sort of an all-ped phase at an intersection. Those are clear, based on your descriptions. You know, those are clearly different things. But I'm wondering, have you come across circumstances where an agency might have had an exclusive ped phase and maybe moved toward an LPI as a replacement strategy to maybe improve or minimize delay, I guess, or improve efficiency?
This is all context related. However, I typically am not a big fan of the barn stance because of the level of delay that everybody experiences. You introduce a whole new phase, and again, remember that it's all context related, so I don't want hate mail coming through. But there's a lot of delay to everyone. When you use the barn stance, which is, maybe some people don't know what a barn stance is, but that is, let's say you took this 2-phase traffic signal and you made it 3 phases where you would have the main line go, then you'd have the side street go, and then you'd have a whole nother phase dedicated strictly to pedestrians. So that's an exclusive pedestrian phase. And what happens is that the pedestrians, no matter which corner or which street they're trying to cross, they have to wait for an entire cycle length in order to be served, except for their portion of the phase. So let's say this is a 90-second cycle, and let's say everyone gets 30 seconds, so they would have to wait a full minute before they could move. And that's true of any of the phases, whether it's the main street or the side street. So there's a lot of delay associated with using the barn stance. The LPI allows them to only have to wait half that time, approximately.
Over to George. George, is that something you all use, the exclusive phase? Also noted in our comment section, some may know it as the pedestrian scramble and the barn stance. George, are you using that in any locations, or is it something you steer away from?
I'd say we mostly steer away from it. We have one example right in the heart of Gallery Place downtown, in the Chinatown area, and it's a special barn stance. I call it a pedestrian enhanced barn stance, because we actually prohibit all turns and we let the pedestrians cross parallel with the green for the 2 phases of the vehicular movements, and then we stop them for about 29 seconds for all red, and a diagonal crossing is allowed. The reason we did that is that, from my research and talking to traffic engineers and planners around the country and who have been doing this for a long time, that the barn stance is no panacea at all for pedestrians. A lot of folks in DC fondly remember it when it was used at many intersections in the downtown area. I think the last one was taken out in 1985. and many cities had them, but they actually did create, as Margaret mentions, a lot of delay, not just for vehicles, but for pedestrians, because you're trying to hold the pedestrians on the corner while the cars go through and right, and then you have to do that for 2 phases, and then they all stop and the pedestrians can go. But a lot of pedestrians didn't want to wait, and they didn't wait, and they would start crossing with the green, and then they would conflict with the right turns. So my understanding was it wasn't all that great, that our memory is somewhat rosy about how well they worked. So we decided to do an unusual version. And I would say the criteria, as Margaret said, very contextually based. You would need huge pedestrian volumes in order to, I think, something that's doable. And I think if you do it, I think you should prohibit turns, because I just don't see pedestrians who operate at intersections across the city where they get the walk signal with the green for the parallel movement, and then all of a sudden you're not allowed to do that at 1 or 2 or 3 or 4 intersections. I think it ends up being a false, kind of a false positive that you're not going to see much benefit. A lot of non-compliance, I think, is what happens. But we did look, and we had about 30,000 pedestrians at the intersection per day in Gallery Place at 7th and H Northwest, and then we had about 27,000 vehicles. So we were able to justify the turn prohibitions because they have a grid and they can make the turns at other intersections, and we simply had more pedestrians than vehicles, and so it was a step in the direction of being more pedestrian friendly.
Well, let's go along with that topic of sort of compliance and perception. We heard in the first case study example in I think it was St. Petersburg, where when they evaluated their treatments there, they did no sort of outreach about these treatments, because I kind of wanted to see intuitively what would people be doing, how would they just behave if they saw this. So I guess my question to you all, both of you, is that a strategy that you see being used in a lot of places where these are treatments that, unlike maybe a hybrid beacon or a rectangular rapid flashing beacon or some other sort of significant change, you want to go out and explain it to the public and make sure people are aware? Is this something that is so intuitive that really isn't necessary? Or is there a strategy you've seen used when these go in? Kind of explain why this is happening and why things are looking different.
Well, this is George. I'm sorry, go ahead, Margaret.
No, I was just going to say, if you could answer that, because I don't really have any information on that. It does seem very intuitive. So. Yeah,
I agree. What I was able to observe from our previous location, which was right at 14th and U in the Midtown neighborhood of D.C., we were up on the 7th floor, and we installed the LPI at 14th and U, and I stood in front of the windows and just watched behavior. And if pedestrians are not watching the walk signal, then they don't get the benefit of it. But the majority of people, just in my anecdotal observation, did in fact watch, look up, and are paying enough attention to the signals that when they got the walk, they started walking, and they were out into the first lane before the vehicles got the green. So I remember seeing a woman with a baby stroller, and she began at the beginning of the walk and was fully beyond the first lane when the green came up and the driver turned, and I thought that was a good example of exactly what we're looking for. But I do think this is certainly something that's intuitive. I think with our experience with hawk signals, pedestrian hybrid beacons rather, and rapid flashing beacons, I'm starting to believe that if you have to explain to the public how a traffic control device works, then you shouldn't use it, because we have some people who say our ped hybrid beacons are too complicated and people don't understand them, but when I observe them, spend time watching the behaviors, there are a few things that happen, but not safety problems that happen, and I see them working fine. But I continue to hear people saying you need an education campaign for this particular device or that particular device, and I'm really, I think the whole point of consistency and expectancy that are the hallmarks and the bedrock of traffic engineering is that if you have to do a major education campaign for a traffic control device, it's a failure. So, and I don't believe any of the three things that I've just mentioned, LPIs, rapid flashing beacons, and PED hybrid beacons, are failures at all. I think they're all very successful in our experience.
Along those lines, so you talked about compliance. Particularly, it seems like a lot of these LPIs, you're talking about a minimum of maybe 3 seconds. You talked about some, George, in the 5-second range. How high? What are some of the greatest lengths of LPIs that you all have come across in terms of the number of seconds that you're holding traffic and allowing the pedestrians across? And at what point do you think the delay is so great to a motorist that there might start to become issues with compliance? That may be anecdotal experience on your part, but I'm just curious if you have any ideas about even where the calculation of the number of lanes and the distances would justify something longer than maybe 8-10 seconds. How long is maybe the maximum you go on something like an LPI?
Yeah, I think you do run the risk of drivers wondering why everyone stopped for so long. I think that's definitely that's again an expectancy issue. Just like pedestrians, when there's a leading interval, when all the cars stop for the crosswalk that you're trying to use and you don't get a walk signal, sometimes people walk anyway because the expectancy is the cars have stopped, it's my turn now. So drivers, I'm sure, also get that, and I think that's why 5 seconds, if you go much beyond 5 seconds, in my experience, I think drivers will start to creep, and then you might induce some non-compliance. That would be my impression, having watched the interactions in DC.
Yeah, I'd like to let people know that if you go to that street film presentation, that in there, if you go to this website and you go watch this, I think they use 17 seconds, and that's a location up in New York. So again, that's an extenuating circumstance. That is not typical. So it's context-based. I know I use that.
Audio might have, you say 17 seconds?
I think it is 17, 1-7.
Okay.
Is there a special geometry associated with that? Because I think that's where you do, we have some diagonal streets and strange intersection geometries, and sometimes there are situations where you can do that, but definitely not, definitely context sensitive there, for sure.
Yeah, and this is Peter, and in that situation, that was coming off of the Lincoln Tunnel. It's one way and multiple lanes, so that was very context with regards to the 17 seconds.
That must have been the entire PED phase to cross that leg, I would assume. I mean, it seems like that's basically an all red, or simply a special PED phase almost.
I don't know any of the other details associated with it.
Just in general, how, from your experiences and what you've heard, how widespread is the use of the LPI when maybe compared to some other pedestrian safety strategies that maybe some that we've talked about in this series? When we have registrations for these webinars, we ask folks about whether this is being used in their communities, and I noted that for this webinar in particular, I think it was probably the lowest percentage of registrants said that they actually are using these. It seems that it is a very intuitive, fairly simple strategy, yet I wonder if it's something that's just not taken off in the way that some other sort of more visible, flashy kind of crossing treatments and strategies are. Any thoughts on how widespread this is, or where it's really taken on and where it hasn't?
I don't know everywhere that it's being used. I would recommend it. It is a very low-cost implementation strategy and very effective. But I don't have numbers as far as who's using it and where.
Dan, did you say a fairly low proportion of people said they're using it in the quiz or in the survey?
Mm-hmm. Yeah, and it's compared to other webinars we've done in this series. The rapid flashing beacons, curb extensions, raised median islands, those sorts of things. So just by comparison, so far it was a fairly low, maybe 25%.
Well, I don't know if this has something to do with it, but I think for an LPI to be an effective countermeasure, you need to have a fairly square, tight urban intersection. When you have slip lanes in a more suburban context, there's no reason, no point to having an LPI because the vehicles are in a slip lane. So you've got to have a lot of intersections that are fairly classically urban for it to be an effective countermeasure. So I know certainly in the DC area, out in the suburbs, there are not very many of those type of intersections that are under the control of, say, the state highway administration. And so, and some of the counties have don't have that many intersections where it would be the appropriate countermeasure or even a usable one. So that might be some reason.
Okay.
I think if you surveyed cities, you'd get a different response, maybe.
Yeah, I think it might be also, that's a good frame of reference, recognizing that you're in urban versus suburban. And oftentimes the suburban cycle lengths are very long already. And a lot of that has to do with the intersections are so large. Right. And the turn radii are large. And so the calculations would just, it could potentially impact the overall efficiency of the intersection just because the geometry makes it an inefficient intersection.
Right.
One other question about compliance. This has been brought up a few times. I think it's kind of an interesting idea. It reminds me of something else I'll mention. People are sort of wondering, or they've heard, I guess, a better way to put it is they've received arguments back against using an LPI because people say that the drivers will become used to it, and when they see the pedestrian signal, the drivers will begin to go even if the light is red. I don't know that I've ever actually heard of this happening. Is this something that you've ever seen, or is this just one of these sort of mythical problems that may or may not happen? I assume you're thinking the drivers are still limited by the fact that they have to stop for a red light, and if there's no right turn on red, they cannot go. But is this more of an enforcement issue if it happens at all?
I have not seen that problem at all here in DC. Even with all the countdown signals, we don't, and that's been studied as well in many other studies, but the drivers are not using are not queuing on the PEDS, the fresh walk signal. I have not seen that at all. There is impatience and there's violations of no turn on red, absolutely, but I think that's independent of the LPI.
Margaret, anything to add?
I would anticipate that it would be associated with the, because it's at the beginning of the phase versus the end of the phase. There's probably a more, and this is anecdotal, of course, but it seems that you would probably have more abuse of signal timing use in the red at the end, where people are running the red lights versus people jumping the red, especially if you have pedestrians already present. If your pedestrians are present, it's unlikely or less likely that you would see a driver trying to jump it.
A question here, some questions about agencies that are maybe still putting in, they have intersections, signalized intersections where they're putting in countdown signals and pedestrian signals where there were none before. What do you think about an agency going immediately to an LPI at an intersection where they're just putting in new countdown signals, or is it something that should be, once the countdown signals are in, it should maybe be looked at as a next step or a second phase approach? Going straight to an LPI where there were not even countdown signals before.
Yeah, I do. I'm just speculating because we have almost basically 100% coverage with PED signals, so we're never in that stage. But I think that's where you do need some of the process policies that Margaret showed from some of the other jurisdictions, because I think if you're putting ped heads and there's extremely low pedestrian volumes, it may be something that you don't need to do, but I think you need to figure out sort of what's the threshold of ped exposure that makes it useful, and I'm not sure it falls into the category of something that should be everywhere no matter what. I think it does depend on the probability of the turning vehicle ped conflict, and I think that is variable depending on the probability of both of those. So I think you need to develop some policies, and Margaret put some good examples out there, Toronto and some other states that have and cities that have done that.
Yeah, George, I agree with that. And if you have a jurisdiction that has a good mix of urban and suburban, then you would want to have some sort of guidelines of saying when you want to install it and when you wouldn't. But otherwise, as far as holding back, if it is a location where you would want to have an LPI, I would recommend just go straight for it.
There's some comments about, in terms of the public perception side of things, that the LPI in and of itself may not be something that drivers get very frustrated with, but it's rather the right turn on red restriction that really causes most of the pushback. Would you say that is the case, that the right turn on red restriction is probably more of a bother to drivers than maybe the LPI giving those pedestrians a head start would be?
I would expect that, well, if you use the blank out sign, then the right turn on red only comes up when you need it. And then the right turners they could actually make the right turn on red if there is pedestrian actuation. Mm-hmm. Or if you use the no turn on red when pedestrians are present.
Yeah, well, I think for both right turn on red and LPI, you want to have a good policy-based process for it, and I think that's where there sometimes is a problem where no turn on red is used as sort of a catch-all for whatever, as a response for a lot of different complaints about intersection safety. I mean, honestly, in talking with the public and people going out and meeting residents at intersections, what they think is a right turn on red problem is most often a right turn on green problem. It is the most frequent conflict at an urban intersection because there is almost a forced conflict. You can turn on a green ball, but pedestrians typically have the ped phase at that point. So I think that you have to be careful not put no turn on red simply everywhere that you get a complaint. You need to have some criteria for no turn on red. But that said, it's drivers who pull up and block the crosswalk and look left and don't look right at an intersection in the city with lots of pedestrians is something we want to stop from happening. So we do have a lot of right turn on red prohibition, but again, we do bracket it by time. So I think it's an important one, but people will violate it if they see very few pedestrians and they see very few conflicts with vehicles and they don't understand why they can't do right on red. Then yeah, you can kind of create a climate of non-compliance if you just slap it up everywhere, and we've done a little too much of that, I think, in some places.
You both talked about some of the criteria you would use to select a location where you'd want to use an LPI, both looking at sort of pedestrian crossings at that intersection, right turn movements, and maybe the conflicts or crashes that you're seeing. Would you say that if an agency is looking broadly at their network and looking at locations to put these in, would the ped crossings be the most important factor to consider when placing an LPI, or is it more that the right turn movements in combination with those ped crossings?
Yeah, I think here it was as we've been doing signal optimization project, what they've looked for, I think the signals team told me that they're looking at when they see more than 50 right turns in a peak hour opposite moderate to high pedestrian volumes. No particular number on that, but you know, fairly solid pedestrian numbers. That's when they would just automatically go with the LPI, the 3-second LPI. So I think it's definitely both. Yeah.
Could you talk again about the use of a lagging left turn phase, Margaret? You talked about this a bit, and I wanted to circle back to it in conjunction with an LPI, and what's preferred in that kind of case? Is a lagging left sort of protected phase something you'd prefer when looking at an LPI?
I'm trying to picture the condition that we would have as far as the lagging left helps the overall condition anyway, because they're waiting, the left turn is waiting for the through traffic. Right. Or they're not waiting, but they're being held back as the through traffic is moving. And so the pedestrians are already moving and clearing out of the way. Sorry. So if they're already moving, then the lagging left already helps that condition.
Okay.
Yeah, I think from my end, I see it as much better at meeting pedestrian expectation at an intersection, at an urban intersection, because when the traffic stops going one direction and pedestrians are waiting to cross that leg, if you have the leading on one side of the intersection, they have to wait another. In DC, we have some tight left turn phases, but you might have to wait another 13 seconds. And we have observed that half of the pedestrians waiting to cross the street that has the left turn phase across it don't wait. Literally 50 to 60% of the people we observed at 14th and U were not waiting. And so the lagging means that the pedestrians get to go when they assume that they would be able to go, because they've now waited for the traffic to stop on the street they want to cross, and they get to go. And then you simply truncate that ped phase enough to pull in the left turn at the end of it. And usually, there still can be some residual conflicts with pedestrians who are very late into the crosswalk, but generally it works better. The only problem is that in the district we don't have very many left turn bays. We often are using through and left movement, and that is impossible to have a lagging because it will back up traffic pretty badly. So when we have a left turn bay available, then that is what we would prefer. Yeah.
For locations where you've got maybe some sort of tightly spaced or intersections very kind of close and concentrated together, downtown areas, is there any concern with, or a pro and con, I guess, between using an LPI at a string of intersections along a particular route, sort of next to each other in close proximity, versus having maybe an LPI at one and then the next intersection someone arrives to, maybe there's no LPI there, and then maybe at the following intersection. Is there a case to be made for consistency within a small area, or is this, again, that we're getting back to the issue of it being fairly intuitive? Pedestrians walk when they see the walk signal and don't when they don't. There's some example. I'll follow up with this, saying there's some examples we've been cited in the comments where there's a lot of intersections within a small area, all using the LPI, and that's almost serving as a just a nice reminder. Every intersection you come to is going to have that same sort of comfortable feeling for a pedestrian, and that seeming like a benefit, but it doesn't seem that that's been something that's been measured or quantified in any of these case studies, is sort of using them within an area.
Yeah, I think it makes sense if the context is similar, the geometrics are similar, even if there's some variation in the PED and turning vehicle frequencies. I think it would make sense to that consistency has some benefit. It's such a minor change to the signal timing, and I think vast majority of people driving or walking through the intersection wouldn't even notice it. But I think it's probably a good idea if you're trying to cultivate that more pedestrian-friendly area, that to have all the intersections in the area that way. Yeah.
Yeah, I agree. Yeah, I think with consistency that makes sense.
Okay. George, I know that you all are doing quite a few different things with respect to enforcement for pedestrian safety, and I'm curious to know if in any of your enforcement activities you've done anything. I won't even really specify it to the LPI, but sort of signalized intersections and trying to reduce these particular turning conflicts at locations where you may or may not have LPIs. Are your enforcement agencies doing any sort of targeted operations at these types of intersections to sort of further reinforce the laws with respect to turning?
I think we've had more activity at sort of our uncontrolled marked crosswalks with the through movement by vehicles, with our law enforcement doing the decoy operation, than we have at the signalized intersections. I've been pushing this for a long time, and I think the awareness is up now on the part of the police. But again, the manpower is limited for doing a lot of enforcement at a lot of locations. But typically, I'll be honest, when they go to the larger signalized intersections that may have LPI, they're usually actually they're watching for drivers who block the crosswalk, who are doing illegal right on red without stopping or things like that. They're targeting pedestrians, honestly, who are going against the signal and walking out in front of cars that have the right of way. So we haven't been, as far as I'm aware, we've not been actually writing tickets for the failure to yield when turning through the crosswalk. But I'm working on getting that awareness up among the police, and we're getting more interest in that.
Okay. All right, very good. Margaret, any enforcement operations you're aware of that kind of go along with this issue and LPI and kind of turning movements at signalized intersections in particular? Because I think most people are familiar with that, with the operations that are conducted at unsignalized crosswalks, where they're more yield controlled. But I'm just curious to know if you've come across anything.
No, I haven't. I haven't touched in the enforcement side.
I will follow on with mentioning that we do have our traffic control officers who work these exact kinds of intersections, and they are very well trained to watch for that conflict and to hold vehicles. And we do have a cadre of traffic control officers who do write tickets, and they have written some of that violation. They can't do both, so we have to have a separate team that adds on at an intersection and moves from intersection to intersection. But that is something that the right on red violations and the turning through the crosswalk is something our traffic control officers do a really good job of targeting.
Very good. Well, I want to thank you both, and that's the end of our question period for today. You answered quite a few of them, and I think we covered a huge range of issues, even beyond the LPI. A lot of different just issues at signalized intersections in general. So I really appreciate you both taking some time to answer those for us and in that question and answer session. Unfortunately, that is all the time that we have today for discussion. I want to remind everybody that you are going to be receiving an email later today. The email is going to contain a link to the archive page for these webinars. And you may have visited this page already. We're archiving all the webinars on the same page to make them a little bit easier to find. So if you scroll all the way to the bottom, that's where you'll be able to find today's webinar. You'll find a link to download the PDF copy of the presentation slides. That'll be up today. And then within 1 to 2 weeks, you'll be able to see the video recording of today's webinar. So if you missed maybe the beginning or the end, or you want to share it with somebody, you'll be able to find the link there. You can go back and watch the whole thing again. I want to let everybody know the other thing that'll be in that email is a link to download your certificate of attendance. So be sure that you keep track of that email. If you are in a group of people and you are the one who registered, you'll be getting that message. So please forward that along to the other people in your group so that they can also download their certificates of attendance. I also want to mention that as you close out of the webinar today, you're going to see a very brief survey that will come up. Please take a few minutes and provide your feedback to us, some comments, and we're really interested in hearing what you have to say about the webinar. We do have 5 more sessions in the series that are coming up, so anything we can do to improve, we really want to follow up on that. So please let us know how you felt about the presentation today. I want to say thank you again to Margaret Kubelins and George Brannion for delivering today's presentations. And I want to say thank you to all of you for attending today's PBIC webinar. We hope to see you on a future session, and I hope you all have a great day.